right, guys, so we're going to circle back to 16 here. Just because this is a little bit of a longer problem. We get negative square root of x minus 11 equals 3 minus the square root of x. Now, it's impossible to isolate the radicals at first. So here, we're going to have to square both sides twice. I'm going to square both sides. Now, from here, negative square root of x minus 11 times negative square root of x minus 11, the negative times the negative becomes positive, the radical disappears, and we're left with x minus 11. Here, we FOIL. Remember, when you square a radical with a plus or minus sign in front of it, you've got to FOIL it out. 3 times 3 is 9. Negative 3x and negative 3 root x, negative 3 root x. The middle term becomes negative 6 root x, and then it's a plus x. Now what's nice here is now I have the problem down to one radical. So I need to isolate that radical. I subtract x on both sides, and I subtract 9 on both sides. What's nice is the x cancels. Negative 20 equals a negative 6 root x. We're going to divide by negative 6. And we end up with 10 over 3 equals root x. And now we're going to square both sides. And my answer is going to be 100 over 9 equals x. Now, the check in some ways is almost as complicated as the problem, but I'll do it anyway real quickly. 100 over 9, I can convert 11 to 99 over 9. 100 over 9 minus 99 over 9 is 1/9. The square root of 1/9 is 1/3, and the negative in front becomes negative 1/3. The square root of 100 over 9 is 10 over 3. 3 can be written as 9 over 3. 9 over 3 minus 10 over 3 gives you negative 1/3 as well. It does work out. But that's how we get rid of a radical when they're on both sides like that. All right, turning the page. Now we're going to a graph. Okay, and what I will do here is I will add a graph on here. So we get the correct look of it. We're going to make this graph a little bit smaller for ourselves. Oops, maybe not that small. Okay, so the first one, f of x equals the square root of x minus 2 plus 1. All right, the domain is x is greater than or equal to 2. You can't go lower than 2 here. You have to have a positive in your radical. And if the biggest number, or the smallest number, I should say, your radical can be a 0, the smallest number your range can be is 1. So the domain is x is greater than 2. The domain is y is greater than or equal to 1. I'm sorry, x is greater than or equal to 2 for domain. Range is y is greater than or equal to 1. The transformation is a shift. We're shifting right 2, up 1. And you always shift from 0, 0 in terms of your shifts from for a vertex. Okay? So, if I want to graph this, which I need to, I always like starting with the radical equaling 0. If x is 2, y is 1. And then I pick numbers that are going to give me a perfect square. 3 minus 2 is 1. The square root of 1 is 1. 1 plus 1 is 2. 6 minus 2 is 4. The square root of 4 is 2 plus 1 is 3. And then finally, I'll go with 11 minus 2 is 9. The square root of 9 is 3. 3 plus 1 is 4. And I'm applying those points. 2, 1. 3, 2. 6, 3. And 11, 4, I'm going to have to guess a little bit off the graph. But that's what my graph should look like. f of x equals the square root of x plus 1 minus 3. The domain, all reals where the x is greater than or equal to -1. Whatever is going to make that radical equal to 0 or bigger. If the radical can't go lower than 0, the range cannot go lower than -3. And your transformation is that shift. So that shift is left 1, down 3. When I go to graph, I'm a big fan of the XY chart. -1 gives me a -3. If I plug 0 in for x, square root of 1 is 1, 1 minus 3 is -2. If I plug 3 in for x, 3 plus 1 is 4, the square root of 4 is 2, 2 minus 3 is -1. And if I plug 8 in for x, 8 plus 1 is 9, the square root of 9 is 3, 3 minus 3 is 0. So -1, 1, 2, -3. 0, -2. 3, -1. 8, 0. And there's my graph. All right, function operations. We have p -2. We don't need equal sign there, sorry. If p of x equals 2x cubed plus 4x squared plus x minus 6. Something like this, wherever you see x, you're plugging -2 in. Make this your first step. Just plug the number in. Don't do anything else. Your next step should be dealing with the exponents. -2 cubed is -8. -2 squared is 4. Plus -2 is really just -2, -6. And now we get -16 plus 16 minus 2 minus 6. And that leaves us with a -8. All we're doing is taking the number in parentheses and plugging it in for x. Nothing more, nothing less. Now, the next one is P of 3a. Same deal. Whatever's in that parenthesis, that's what you plug in for x. So, 3a cubed plus 2 times 3a squared plus 3 times 2a minus 1. 3a cubed. 3 cubed is 27. A cubed is a cubed. 3a squared is 9a squared. Now I do the multiplication. 27a cubed plus 18a squared plus 6a minus 1. And there's nothing to simplify there. That's the answer. When you plug something in with a variable like that, you're not going to get an answer that's a number. I won't mention names here, so no one gets embarrassed. I mistakenly put 2a there, which obviously would make this a little bit different, which means this number right here is going to be 9a instead of 6a. And that's the correct answer right there. Let's put that a minus sign right there. Okay, so that is now my correct answer. So now for an f minus g, the x, we're left with f of x equals 3x squared plus 2x minus 5. We're left with g of x equals 5x cubed minus 6x squared plus 7x minus 9. And if we're subtracting, it's f minus g. So 3x squared plus 2x minus 5 in parentheses minus 5x cubed minus 6x squared plus 7x minus 9. I am a big fan of writing the first expression over and distributing the negative, which basically changes the sign and everything in the second term. Combining my like terms, negative 5x cubed plus 9x squared minus 5x, and then negative 5 and 9 is a positive 4. And that would be my answer. On to 23. When it's a closed dot, we multiply. When it's an open dot, it's a composition. So in this case, we have the closed dot. So that means we're going to be multiplying f of x, which is 3x squared minus x plus 5, and g of x, which is negative x plus 7. This is kind of like FOILing. Three x squared minus x plus 5 times a negative x plus 7. 3x squared times negative x, negative 3x cubed, plus 21x squared, plus x squared, minus 7x, minus 5x, plus 35. And we're going to look to combine like terms. Negative 3x cubed plus 22x squared minus 12x plus 35. There's your answer. When we combine terms or do a composition, this is usually how it'll look. F of x equals x squared minus x plus 5, and g of x equals x plus 2. And essentially what I'm allowed to do is I can replace the g of x with what it equals, x plus 2. And then from there, everywhere I see an x in the f of x formula, I plug x plus 2. So we get x plus 2 squared minus x plus 2, and we always plug it in parentheses. The x plus 2 squared, if you need to, it's sometimes not a bad idea to do it off to the side, but it is imperative that it gets FOILed out. X squared plus 2x plus 2x plus 4. Any parentheses squared like that with an addition or subtraction has to be FOILed out. So this becomes x squared plus 4x plus 4 minus x minus 2. That gets distributed through the parenthesis plus 5. So x squared, 4x and negative x, 3x. 4 minus 2 is 2, and 2 plus 5 is 7. There's my answer. Now when we reverse the order, on the next one, we get g of f of x. Right? My f of x here happens to be x squared minus x plus 5. So now for my g of x, wherever I see x, I plug the x squared minus x plus 5. Okay. So we end up with, and this is the same thing as g of f, the open dot, x. They're the same thing. Okay, and we end up with x squared minus x plus 5 plus 2. I just plug that whole thing in wherever I see x. And simply x squared minus x plus 7 is our answer.